A function is a relationship that pairs each input with exactly one output. The domain is the set of all possible input values of a function. These are your x values. The range is the set of all possible output values of a function. These are your y values. Sometimes they will be labeled input and output instead of x or y or domain and range. Here you want to identify the domain and range of each example. So for example 1, when we're looking for a domain, we are looking for the x values of our ordered pairs. Our first x value is 1. We want to put them in order from least to greatest. Then we have 3. Anytime a number shows up twice, we only write it once. And then 5 is next, and then finally 9. Then we're going to look for our range values. Those are our y values. The smallest y value is 2. That comes up twice, so we're only going to write it once. And then 4, and then we have 7. Make sure you write these in brackets. On number 2, we're looking for the domain, your x values. The smallest x value we have is a 3. And then our next smallest x value is a 5. Our next one is a 6. And then we have 8. And then our largest x value is 9. For the range, the smallest y value we have is 0. So we'll start with 0. Our next smallest y value is 1. Then we have a 2, followed by 5, and then our largest y value is 7. When an equation represents a function, the variable that represents input values is the independent variable, because it can be any value in the domain. The independent variable is the x variable. The variable that represents output values is the dependent variable, which is your y value, because it depends on the value of the independent variable. The function y equals negative 3x plus 12 gives the amount y of juice remaining in a bottle after you take x gulps. Identify the independent and dependent variables. The independent variable is your x value, and that is the number of gulps that you are taking. The dependent variable is your y value, and y is the amount of juice that is remaining in a bottle. The question then asks us to find the range with the given domain. You are given your 5 values for the domain, 0, 1, 2, 3, and 4. To find the range, we are going to plug those domain values, or x values, into the equation for x and solve for y. When we plug in 0, we get negative 3 times 0 plus 12, or 0 plus 12, which is 12. So that's going to be one of our range values. Next, we will have to plug in 1. So we'll get y equals negative 3 times 1, which is negative 3, plus 12 more gives us 9. Now we're going to plug in the 2. We'll have negative 3 times 2, that's negative 6, plus 12 more gives us a positive 6. Now we're going to plug in the 3 of the domain. So we have negative 3 times 3, which is negative 9, plus 12 gives us 3. And then finally we're going to plug in the 4. So we have negative 3 times 4, plus 12. Negative 3 times 4 is 12, and 12 plus 12 is 0. Sorry, it's negative 12 plus 12, which is 0. So then you just want to put them in order from least to greatest. 0 was the smallest, then 3, 6, 9, and finally 12. Here we have a table, and it asks us to find the domain and the range. The x value, remember, is the domain, and the y value is the range. So you want to put them in order from least to greatest. So for the domain, they are already in order, 0, 1, 2, 3, 4. For the range, the smallest one is 2, then 3, and then 4. Remember, they repeat, we do not write them twice. Now we're looking at ordered pairs on a graph to find the domain and range. When we're looking for the domain, that is your x values. We go from left to right on the graph to get them in order from least to greatest. So the first x value we find on the graph is at -6. Then we continue to the right. Our next x value is at -1. Then we're at 0. Our next x value is at 2. And then our last x value is at 7. When you're looking for the range, the y values, you start from the bottom of the graph and work your way up. The smallest y value is -5, then -3. Our next one is at 0. Then we have one at y equals 3. And finally one at y equals 5. We're going to do the same thing for number 6. For the domain, our x values, we're going to start on the left side of the graph and work our way to the right. We have an x value at -8. We have two x values at -3. And I wrote -5. Make sure you change that to -3. And then you have one at -1, 3, and then finally 4. For your range values, we're going to start at the bottom of the graph and work our way up. Our smallest one is at -5. Then we have one at +1, 4, 5, and then finally the one at 8. Then for the next one, you're going to work your way from left to right again. So just write down every x value that goes with your point from left to right. You want them in order from smallest to greatest. And then you're going to do the same thing with your y values for the range, working your way from the bottom to the top. You have -8, -5, -2, 1, 4, and then finally 7. And the last graph here for your domain, your x values. Our first one is at -2. Then we have an x value at -1, 0, 1, and then finally one at +2. For your range values, you're going to work your way up from bottom to top. First one is at 0. Then you have two of them at +1, but we only write it one time. And two of them also at 4, but we also write that just one time. A relation pairs inputs with outputs. A relation that pairs each input with exactly one output is a function. So in order to be a function, each input must have exactly one output. That means that each x only goes to one y. Each x value only goes to one y value. X values cannot repeat with a different y value. It says same, but it should say different. So in order to determine if a group of ordered pairs is a function, you look at the x values. See if any of those x values repeat. If they do not repeat, it is a function. So none of these are repeating, so this one is a function. On example 10, we have two 3s here. Each 3 has its own y value. If those y values are different, it is not a function. If those y values were the same, it would be a function. When you're looking at a table, your input is your x values, the output is your y values. So looking at your input values, do any of those repeat? Here we have 2 zeros. Then we're going to look at the output. One is a 5, one is a 6. Since they are different numbers, it is not a function. Had they both been a 5, it would be a function. Here's another example with a table. Your input is x and your output is y. We have 3 different inputs, so this one is a function. Now we're looking at a mapping. So this takes your input values, your x values on the left-hand side, and maps them to an output value or y value on the right side. So our inputs are -9, -2, 5, and 12. -9 pairs with 0, -2 pairs with 5, 5 pairs with 10, and 12 pairs with 10. None of those x values are repeating. None of them are pairing with more than one thing, so this is a function. Example 14, we have one input, that's -3, and we have 3 different outputs. -3 is pairing with 1, 2, and 3 different y values. If we were to write these as ordered pairs, they would look like -3, -2, -3, 4, and -3, 8. So that x value is repeating with 3 different y values, so this is not a function. Now there's something called the vertical line test. This is another way to tell if a relation is a function. A vertical line should only touch the graph at one point in order for it to be a function. If the vertical line touches the graph at more than one point, it is not a function. So if you look at the one on the left, that vertical line only touched one time. On the right, it touched twice, so that's why it was not a function. Alright, on example 15, we're going to draw in some vertical lines. Here's my first one. It only touches one time. My second one, this touches once and touches twice, so it touched more than once, so it's not a function. On example 16, I'm going to do the same thing. I'm going to draw in some vertical lines. Each vertical line should only touch the graph one time. If it touches it more than once, it's not a function. Each vertical line here on 16 only touched once, so 16 is a function. And we have your last two examples. 17, let's draw in a vertical line. This first vertical line touched it one time and 2 times, so it touched it more than once, so it is not a function. And then our last one is example 18. We draw in our vertical line here. It only touches it one time. Our second vertical line only touches the graph once. Third one, once. And this last one also touches it once. So each vertical line only touched the graph once, so this is a function.